All right. Now that we have a good grasp of RAG pattern and how to implement it using SQL search, let us elevate our RAG skills by exploring the power of similarity search and embeddings. These techniques are essential for effectively retrieving relevant information from vast datasets or document collections, enabling us to build more accurate and responsive RAG systems. So, what is similarity search? Similarity search is a process of finding items from a dataset, large dataset, that are most similar to a given query item based on certain defined criteria. For example, semantic search is a type of similarity search, which specifically focuses on understanding the meaning or semantics behind the data, particularly in natural language processing. Thus, we are able to retrieve data which is semantically similar to the user query. Or other examples of similarity searches are image similarity search, or genome sequencing search, or even face recognition search. Then, what are the advantages of using similarity search in our RAG pattern? See, similarity search ensures that the retrieved data closely aligns with the query, in context as well as meaning, rather than relying on simple keyword matches. This is very powerful, as now we have the ability to search based on semantics rather than only keywords. Also, similarity search operates efficiently even on large datasets by leveraging something called as vectorized representations, which we will see soon. Finally, similarity search can work across different data types: text, images, audio, etc. by representing all of these as embeddings in a shared vector space. As I said, we will see the details on embeddings or vector databases soon. Now, let us go back to our IT support ticket resolution system example that we saw in the last lecture to explain how similarity search is implemented using embedding. Don't worry about the word embeddings for now, we will see it soon. You see, the user uses high temperature now instead of his laptop getting heated as the problem statement. So, if we use our SQL search, we won't get anything back as the query doesn't have the keyword heat which is present in the support database. So our RAG pattern won't work with simple SQL search in this case. This is where similarity search comes in play. So in the retrieval step, instead of simple SQL search, we will do similarity search. We do this by creating something called as embeddings or data stored in vector space of the support database. We create the embeddings of the user query as well. We now match all rows in the support database where the embeddings of the user query are closest. With this matching, we are able to retrieve all rows which are essentially semantically same as words high temperature. Thus, we will be able to get the row which has the word heat in it as well, since now we have used semantic search instead of keyword search. Next two steps remain the same. So, the key to similarity search is the embeddings. Let's see them now. Embeddings are basically dense numerical vector representations of data. Numerical vectors, for those who are not aware of them, are essentially numerical arrangements of any data. This numerical representation captures the key features, relationships, or meaning of the data in a compressed and continuous form. So we transform non-numeric data such as text, images, or audio into a fixed dimensional vector space for efficiently processing and for comparison. For example, the word apple can have numerical vector representation as shown over here. Vectors have angular brackets around the numbers and they are single dimensional or multidimensional. Here we have single dimensional representation in a single row, but we can have multiple rows as well, which would then be a multidimensional vector. Now, please don't get overwhelmed with all this mathematics because we don't really need to directly deal with this mathematics. We have libraries which will do this for us. We only have to call these libraries. Here, we just need to be aware that we can do similarity search using vector representations or embeddings. One thing to understand is that similar meaning sentences will have numerical vector representations which are very close to each other. As an example, here you can see the embeddings or vector representations for the word king and man are close to each other than the word vector representation for queen. Obviously, because king and man are semantically related. So, as an example, if the user asks for health benefits of blueberries, then out of the three documents from the document database, if we do a similarity search on these headings, the first document stating blueberries are good source of antioxidants will have embeddings closest to the embeddings of the user query. Let us walk through the same IT ticket resolution example now using embeddings and similarity search. The user prompt now has high temperature as the issue. The application layer creates the embeddings of this user query. Also, we have embeddings of all the rows of the knowledge database already present. The application layer then compares these two embeddings and get the embeddings from the knowledge database which are closest to the user query embeddings. It then gets all the rows for these matching embeddings, uses this data to update the user prompt, and then similar steps to the LLM getting back more accurate response. With this, I think you have a good grasp on how similarity search and embeddings work in an RAG pattern. So, to summarize retrieval augmented generation, there are several advantages of RAG pattern. RAG empowers GenAI systems to access and process vast external knowledge sources, and this helps us to get more comprehensive, up to date, personalized, and accurate responses. RAG significantly reduces hallucinations of the GenAI systems and unlocks many use cases where fact checking, real time updates, or personalized recommendations are critical. Finally, RAG increases efficiency by avoiding unnecessary processing by selecting only the relevant information passed to the prompt. RAG is implemented using three steps: retrieve, augment, and then generate. And finally, similarity search using embeddings play a crucial role in the retriever portion of the RAG pattern. That concludes the theory portion for retrieval augmented generation or RAG pattern. We will now see some practical examples.